Modern marketing teams demand strict statistical significance before approving a single dollar of ad spend. Yet, when measuring their visibility in AI search, those same teams are building strategies around single query screenshots. Generative AI engines are not fixed databases. They calculate and generate answers probabilistically, building responses fresh every single time. Because of this generative behavior, asking an AI the exact same question twice will frequently yield completely different brand mentions. This creates a hard operational rule for AI analytics. Checking your visibility with a single prompt gives you an anecdote, not a trackable metric. The standard industry methodology relies on a quick check audit. In this model, a buyer question is run exactly once to see who shows up. To capture true generative behavior, you have to sample the probability distribution. That requires asking the same questions thousands of times to see what the AI says reliably. It is the difference between a single pass and a 1,500-run framework, where 30 distinct buyer questions are independently queried 50 times each. If you fail to scale the sample size to match the volatility of the engine, statistical noise will completely swamp your true visibility signal. Stripping away human-like AI variance to extract a board-ready metric is solely a function of statistical depth. Consider a baseline scenario. This diagram plots a brand that genuinely appears in exactly 5% of AI answers. If we apply the standard single-run audit methodology to this brand, it produces a margin of error of plus or minus 9 points. A range from 0 to 14% is functionally useless. Leadership cannot tell if the brand is totally invisible to the market or if it is the category leader. Appearing in an AI answer is mathematically identical to an unbalanced coin that only rarely lands on heads. The rarer the event, the more extreme the number of flips you need to pin down the true probability. Tracking these rare yes or no events requires a strict statistical standard known as the Wilson confidence interval to accurately bound the uncertainty. Now, let's apply the 1,500-run methodology to the exact same baseline brand. The interval collapses to a plus or minus 1.1 margin, spanning precisely from 3.9 to 6.1%. Placed side by side, the difference in reality is stark. That tighter bracket transforms a wild guess into a highly precise number that a team can reliably benchmark, report, and act on. Reporting a single percentage point in AI search without showing the 95% confidence range is a false precision. Pushing the margin of error down to around plus or minus 1.5 points is the absolute threshold for making AI search metrics actionable. If we know the total volume required, we have to look at the exact mechanics of execution. Specifically, how many runs per individual prompt are mathematically required to trust the data. This graph plots the margin of error against the number of runs per prompt. Notice the dramatic plunge as query runs scale from 10 to 30, but as the sequence approaches 50 runs, the line flattens significantly, demonstrating diminishing returns. 30 to 40 runs represents the efficiency sweet spot. 50 runs acts as a slightly conservative default to absolutely guarantee statistical safety. With the depth per prompt established, we must pivot our analysis to breadth, the 30 distinct buyer questions we ask the AI. This chart maps 30 prompts against share of voice. A brand score is rarely even, carried by a few hero prompts that spike high, while a large section flatlines. Take note of these 9 specific prompts. They completely fail to surface the brand even once. Because our high-volume methodology removed random variance, these 9 dead prompts are not bad luck. They represent verified, concrete gaps in the content strategy. Query depth locks in the reliability of the overall metric, but query breadth isolates the exact levers needed for growth. This underlying variance also dictates how we evaluate the competition. Generative AI breaks the core mechanics of traditional competitive intelligence gathering. If you rely on a single run check, you log whatever random competitor the AI happened to hallucinate in that exact microsecond. This rarefaction curve maps prompt runs against distinct rivals found. As runs increase, the engine continuously generates completely new rival brand names. We can split this data into 2 realities, a climbing upper section and a lower group that quickly plateaus. The climbing upper section is the long tail. This is statistical noise, irrelevant, one-off brand mentions generated purely by the AI's inherent variation, averaging 0.41 new brands per run. The plateauing lower line represents your core competitors. Rivals that actually matter to your market share consistently surface and stabilize within the first 25 runs. This is the trap of the shallow audit. Marketers using a low-run model constantly chase a volatile, ever-changing long tail of phantom competitors. Crossing that 25-run threshold allows a team to confidently ignore the long tail noise and focus their strategic efforts purely on the stabilized core group. True competitive mapping in an AI search environment is impossible without enough sampling depth to separate persistent market signal from probabilistic noise. Let's bring these two competing methodologies back together for a final, practical head-to-head comparison on tracking performance over time. This chart shows the reality of attempting to track share of voice month over month using a one-run methodology. It results in a chaotic, jagged graph with massive overlapping error bounds that obscure any actual trend. In this chaotic framework, a legitimate 5-point gain in visibility is totally invisible. It is swallowed whole by the plus or minus 13-point margin of error. Now look at the 1500-run tracking architecture applied across the exact same 8-week timeline. We see a smooth, clear trend line guarded by tight 95% confidence whiskers. Notice this specific week, where the upward trend clearly escapes the boundary of the previous week's uncertainty. This is the operational reality. A plus or minus 1.5 margin of error means a 5-point jump is no longer a guess. Instead, it is mathematically proven, board deck-ready growth. It is time to stop treating generative engines like static databases and demand strict statistical rigor in measurement. In the era of generative search, raw data depth is the ultimate dividing line between an anecdotal screenshot and a strategy you can bet a marketing budget on.